Hello everyone, hope you're fine today. We're gonna continue the last part of the electricity unit. It's gonna be about the average power, power factor, and power dissipated. Given that the current is Im sine omega t plus phi, that's given, and u of t is um sine omega t, such that the power at any time is u of t times I of t, which is Im sine omega t plus phi. However, this equation is a bit complicated. So let's go for something which is simpler for our curriculum. So we have the power average, which is ui cosine phi. Of course, this is in volts, this is in amps, and that's cosine phi. Cosine phi is the power factor, and that's the decisive factor that will give us some answers for the average power. However, as a revision, effective voltage is U maximum over square root of 2 and I effective is I maximum over square root of 2. However, what is the power dissipated or power loss, sometimes we call it? It is the rate at which electrical energy is delivered to a resistor in the circuit is given by Ri squared, and it will change and convert the electrical power into thermal power or light or any other form of energy. So P is equal Ri squared such that I is an instantaneous current. Okay, that's I actually, the instantaneous current at any time. The heating effect produced by an AC current with a maximum value of I maximum is never the same as that of a DC current of the same value. So there are some special cases to find the power. Let's begin with the first one. If the load connected to the 2 points is a resistor of resistance R, then U and I are in phase, then phi is 0, then P average is equal Ui cosine phi, and cosine phi, cosine 0 is 1, so it will be Ui, but U actually is Ri, so Ri times I, it will be Ri squared. All energy is lost as heat or thermal energy, or all energy is transformed, better than the word lost, is transformed into heat or thermal energy. If the load is purely inductive, so only L, what happens? U leads I by phi, so minus pi by 2 because I lags U by phi. So if I lags U by phi, this means that U leads I, so I lags, that's why this is actually minus. Whether it is minus or plus is the same actually. Cosine of minus pi by 2 is 0 and cosine of pi by 2 is 0. 0 times anything is 0, so no energy loss inside the inductance, which is a purely inductive coil without a resistance, without an iron core. If the load is purely capacitive, what happens? I leads U by phi, which means that it is pi by 2. If it's pi by 2, the same answer, average power is 0 and no energy loss inside the purely capacitive circuit which has only C. In an RLC circuit, then what is the consumption of power? The power consumed or lost is actually called dissipated, which is Ri squared. Please resolve the application 10.6, page 192 from the book. Have a nice day and enjoy physics.